So now we're going to go ahead and talk about a line reflection. A line reflection is a transformation that can be thought of as folding or flipping an object over the line of reflection. It is also an isometry. And once again, we keep hearing this word isometry. And isometry, rigid motion, they are interchangeable words. They are synonyms. So a reflection can be seen in water, mirrors, or maybe even a shiny surface. We've seen these in our everyday lives, but never have actually looked at them in the coordinate plane. So what properties are preserved in any type of reflection? And again, a reflection is an isometry. So the properties that would be preserved would be the distance between points, parallelism, the size. Okay, so nothing about this shape changes. So here's some examples of lines of reflection in the coordinate plane. So let's say we're reflecting this triangle ABC up here in the coordinate plane. My line of reflection is the x-axis here. If we go ahead and take a look, if we folded the paper up, they would really stamp on each other and be the exact same thing. But a quick way to map a reflection is to count the amount of boxes on the grid away. So this is 2 boxes away from the line of reflection. It's also 2 boxes away this way. This point B is 4 boxes away. So B prime would be 4 boxes away as well. Same goes for A. This is 1 away. This is 1 away. We'd get our reflected shape. So we go from ABC to the new one here, which is A prime, B prime, C prime. Now we can reflect over the x-axis, or the y-axis, sorry. We can really reflect over any line that we want. So let's say we reflect over this y-axis here. I'm going from A, B, C to A prime, B prime, C prime. So I reflected from here to here. Again, if I count my boxes, A to the line of reflection is 1. Same from the line of reflection to A prime. If I count from B to the line of reflection, that's 5 boxes away. So B prime is also 5 away. Same goes for C, and then C prime. So we could, again, reflect over any line that we want. Now, you may see the y equals x axis being reflected over. So y equals x is a kind of slanted line that goes between the coordinate plane. Now, this is where you have to be careful. So let's say it took me, we'll talk about point B first. We had to go down 1, over 1 to get back to the line of reflection. That means we have to do the same thing over here. Now, a good way you can count this, I like to go across the boxes. So we went across 1 box, we go across another. Now let's take a look at C. I go 1, 2, 3. So now here I have to do the same thing. 1, 2, 3. And I end up at my C prime. Same goes for A. I went 1, and then I go 1 again. So being reflected over a line like y equals x, we have to be careful here. And remember, it's a mirror image. So if you folded this up, they should stamp on top of each other. And now this is just reflecting over any line. So it's not always going to be the y-axis, the x-axis, or y equals x. You may see an instance where it says, okay, let's reflect over the line here, x equals 2, or x equals negative 2, sorry. You would do the same thing. You count how many boxes away it is. So this is 1, this would be 1, and then same thing goes for all points. So let's take a look at an example down here. So if we wanted to graph this triangle as a reflection, we'd obviously have point B here again. We went over 1 for this. We'd go over 1 for this. Here's my A prime. Same thing goes for C. I count over 1. I'd have to count over another 1 box here. So there's C prime. And now I could go ahead and connect these points. Connect, connect, connect. There is my reflected triangle. So let's go ahead and look at the first example. Now, here we are reflecting a point over certain lines of reflection. As you see down here, this is how we denote a reflection. So it's a lowercase r followed by the line of reflection and then the point that we're actually reflecting. So we're working with the point -3, 5. So here is point A. So let's first go ahead and reflect it through the x-axis. So if I count down 1, 2, 3, 4, 5, I'd have to go 5 this way as well. 1, 2, 3, 4, and then 5. So here would be my point A prime with a reflection through the x-axis. So that new point would be -3, -5. And again, you could follow along with this up here if you'd like, but I would like you to know actually what you're doing when you're reflecting instead of just plugging in to a change of coordinate. So then let's go ahead and reflect this across the y-axis. The y-axis in red. If we reflect point A, so over 3, we have to go over 3 this way. There is my new point, A prime. So A prime is now 3, 5. Let's go ahead and reflect over the y equals x-axis. So we'll do that in yellow. The y equals x-axis cuts between here, here, goes up. And there we have it. So now what happens if we reflect? So again, I count across boxes. So 1, 2, 3, 4. Have to go down this way. 1, 2, 3, and then 4. So here is my A prime if I reflect through the y equals x-axis. So that point would now be 3, -5. And then my last one would be the y equals -x-axis, which goes across in this direction here. So 1, go up this way, go down this way here. This is the y equals -x-axis. So again, I'm reflecting this point here. I counted over 1. It would end up right there. Okay? Nothing too crazy here. So that point is -5, 3. It just depends on what axis you're reflecting over. So make sure you know your y-axis, your x-axis, and then your other axes, which are y equals -x, and then also the y equals x-axis. So now we're going to go ahead and do the same thing with point E down below. So point E is -3, -4, which ends up right here. So the first thing we're going to do is reflect point E across the line x equals 3. Now, the graph of the line x equals 3 is a vertical line through the x value 3. So there is this line of reflection, and that's x equals 3. We go over it and we count 1, 2, 3, 4, 5, 6, and that means we have to go 6 this way. 1, 2, 3, 4, 5, 6. Here is our new point, which is E prime, and that point is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 9, -4. So now let's go ahead and reflect this over the line y equals -2. So y equals -2 is a horizontal line across the y value, -2. So this is the same process. We count 2 away, then we count 2 away again. So the point reflected across the line, y equals -2, would end up being -3, 0. And then the last one, we're reflecting across the line, x equals -3. X equals -3 is the point that the original point is on. So this is x equals -3. If you reflect that across that line, it's just going to be the same point, which is -3, -4. So for example 4, we're reflecting the triangle ABC across the line y equals x. So it's key here that you know what the line y equals x is. That's one of the axes That's the common line of reflection. So it's usually the x-axis, the y-axis, the y equals x-axis, or the one that goes across here, that's the y equals negative x-axis. But that doesn't necessarily matter at the moment. We're only working with the y equals x-axis. So here's our triangle that we were given. Now, we have to reflect it across this line. So let's go ahead and start out with point C first. C is on the line of reflection. If we reflect a point that's on the same line of reflection, it just stays. It stays what we call fixed. So if we look here, now we have to count the boxes to get to where we need to go. So let's start with point A. If we look at point A is about 1 and then a half. So we go a half and then 1 again. So there's our new point A prime. That coordinate changed to 1, 4. Our next point we're going to work with is B. So if we count from B, B goes over to the line by counting boxes here. So we count 1, 2, 3, 4, and then a half. So we count a half. 1, 2, 3, and then 4 again. So if we were to connect these now, here is the reflected triangle. And as you can see, if you folded this paper up and connected these triangles, they would stamp on each other, meaning it would be the same exact triangle. So our new coordinates were B prime ends up being 1. And then we have to count up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, sorry, I believe that might be, yes, 0.9. So then for C, it's the same exact point. For number 5, we are reflecting the triangle XYZ across the line x equals 2. So there's my line x equals 2 drawn here. It's a vertical line through the x value 2. So to reflect, we count. There is my y prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There is my z prime. And then if I count with x, there is my x prime. So that's how I would reflect my triangle. Now all you have to do is write out the points on the side of that new triangle. For 6, we're working with something a little different here. We have this line M. Now we're asked to reflect a bunch of points across this line M. So first, we're starting here. We're reflecting the point C across line M. So if you went across line M, that would be point B if we folded up this pentagon. Now we're reflecting D across line N. That's this line here. So D would go to point C. Now we're reflecting E across line N. So that means if we folded this over line N, we would get point B. For 4, we're reflecting A across line N. So let me erase here so we don't see these lines. We are reflecting A across line N. A ends up on line N, so it is the same exact point A. Now for this one, we're reflecting AB, which is a side, across line N. So if you flipped this over onto here and folded up a piece of paper, it would end up where EA is. Lastly, we're reflecting DE, this line segment here, across line M. So if you folded your paper up this way, that would end up on EA as well.